The overall electrical charge are same throughout the capacitor, but the overall voltage is never same. It is the summation of all the voltage. Now this is the equivalent capacitor circuit. You can see that the Q equals to Q1 equals to Qt, Q2 equals to Q3. That is the same. So C equals to, by using the equation C equals to Q by V or V equals to Q by C, we can just find out that by using that equation V equals to Q equals to C equals to Q by V. So V equals to Q by C. Now V equals to V1 plus V2 plus V3, and in the general form like Vn. So V equals to Q by C, V1 equals to Q1 by C1, V2 equals to Q2 by C2, Q3 by C3, and up to Qn by Cn. But as we all know, in a series form, series circuit, all the Q is same. So just cancel out all the values of Q, and we can see that 1 by C, that is total, equals to 1 by C1 plus 1 by C2 plus 1 by C3 up to 1 by Cn. This is the final equation for capacitance whenever you are connecting in a series form. This is the basic process which we already discussed, and this is the final equation. If you want to find out the general form of the capacitor or equivalent capacitance in a series circuit, then it is a 1 by CE equivalent sigma I equals to 1 to n number of capacitor connected in a series form into 1 by Ci. This is the equation for the series capacitance. Now just take one example of the series capacitor. Here you can see that between two terminals A and B, there are three capacitors connected in a series, C1, C2 and C3. All the capacitor has the different value like 0.1 microfarad, 0.2 microfarad and 0.3 microfarad, and the overall voltage which we are applying between the two terminals A and B are the 12 voltage. So just now find out the total capacitance, that is 1 by Ct. So we can using that equation 1 by Ct equals to 1 by C1 plus 1 by C2 plus 1 by C3, that gives you the 1 by 18.33 into 10 raised to 6 microfarad. So now just reciprocal, take the reciprocal of that equation, we can find out that Ct equals to 0.055 microfarad or 55 nanofarad. So this is the overall capacitance generated due to the 12 voltage to that A and B terminal. To find out the equivalent capacitance of the three capacitor connected in series with a 24 voltage battery. This is the figure. 24 voltage battery applied to the C1, C2 and C3. C1 has the 2 microfarad, C2 has the 4 microfarad and C3 has the 6 microfarad. So with the help of the equation of the 1 by C equals to sigma I equals to 1 to n 1 by Ci, wherever n is 3. So 1 by Ce equals to sigma I equals to 1 to 3 1 by C3. So just using that equation we can find out that 1 by C equals to 1 by 2 microfarad, 1 by C1 plus 1 by C2, C2 is 4 microfarad plus 1 by C3, C3 is a 6 microfarad. So by solving that we can find out that 1 by C equals to 0.917 or 1 by C, so C equals to 1.0.917 microfarad. It gives you the equation C equals to 1.09 millifarad, that is a 10 raised to minus 3 farad. So ultimately if you are connecting the 10 to 24 voltage battery to the series capacitor, then you can get the equivalent capacitor is 1.09 millifarad. So this is the equivalent circuit How you can just replace all the 3 capacitor with the one equivalent capacitance, that is 1.09 microfarad. Just note down that one important point, that in the series form of a capacitance, the equivalent capacitor value of the equivalent capacitance is always less than the least value of the capacitance. In our figure, in our circuit, that the least value for the capacitor is C1, that is 2 microfarad. So our equivalent capacitance value is 1.09 microfarad, that is least value of the C1. So this is again one of the hint for your problem solving. Now the total charge at the each capacitor, if you want to find out the total charge, that is Q. So Q, again by using the equation Q equals to CV, as total capacitance is 1.09 microfarad, and that is the V, that is the 24 voltage. So by solving that, we can find out that 26.2 millifarad, and the overall capacitance for the all the series capacitors are the same. So ultimately the QT equals to become the Q1 equals to Q2 equals to Q3. Now the voltage across the each capacitor, that is V1, V2 and V3. As we all know that the voltages are different in all the capacitor. So V1 equals to Q1 by C1. Using that equation, we can find out that 13.1 voltage which is generated toward the capacitor 1. The capacitor 2, that is Q2 by C2, using the equation 6.55 volt, and V3 equals to Q3 by C3, that is 4.37 voltage. Now friends, if you make the summation of V1, V2 and V3, you can achieve the value which we already applied, that is 24 voltage. See that 13.1, 6.55 and 4.37 all are summation and make the 24 voltage. This is one of the shortcut of the series form. To find out the equivalent capacitance, the product of all the capacitor to the summation of all the capacitor. So CE equals to C1 C2 by C1 plus C2 if we are using the 2 capacitor. Just simple example, C1 is 3, C2 is 6 microfarad, so 6 into 3, that is 18 microfarad, by divide by 6 plus 6, that is 9 microfarad, that gives you the 2 microfarad. Now the capacitor in parallel. If you are applying the same source to all the capacitor, then the circuit is commonly known as in the parallel form. Here you can see that the C1, C2 and C3 get the same source voltage. In a parallel form of capacitor, the value of voltages are same because all the capacitors get the same voltage. So you can see that Vt or Ve equals to V1 equals to V2 equals to V3, or in the general form equals to Vn. But the charges generated in all the capacitors are different. So we can make the summation of Qt equals to Q1 plus Q2 plus Q3. So again, just find out the equivalent value of the capacitance using the equation C equals to Q by V or Q equals to CV. We can see that the Q equals to Q1 plus Q2 plus Q3. Now Q equals to CV equal to Q1 equals to C1 V1, Q2 equals to C2 V2 and Q3 equals to C3 V3. But all the values voltage is same, so we can just remove all the voltage from the equation and we can just get that C equals to C1 plus C2 plus C3. So this is the reciprocal of the series form of capacitance. So ultimately the equivalent capacitance value becomes C equals to sigma I equals to 1 to N into Ci, where N is the number of capacitor in a parallel form. Now this is the example based on the parallel circuit. Here just to find out the equivalent capacitance of the 3 capacitor connected in a parallel form with the 24 voltage battery. The value of the capacitor C1 is 2 microfarad, C2 is the 4 microfarad and C3 is the 6 microfarad. All are connected with the parallel form. So using that equation we can see that the C equals to C1 plus C2 plus C3 is 2 plus 4 plus 6, 6 plus 4, 10 plus 2, that is a 12 microfarad overall capacitance generated in the circuit. You see that. Remember one thing, in a parallel form of capacitor, the every equivalent value of the capacitor has the greater the value of the almost higher the value of the capacitor. Now find out the total charge, that is QT, and the charge across each capacitor, that is 24 voltage given by the battery C1, C2 and C3. Individual value of the capacitor, that is 12 microfarad. CF is the total amount of the 12 microfarad. Now V1 equals to V2 equals to V3, that is 24 voltage. So ultimately, using the equation C equals to Q by V, Q1 by V1, but the voltage of V is same, 24 volt. So we just get that 20 microfarad to the 24 voltage is give you the equation total charge, that is 288 microcoulomb. So Q1 equals to C1 V1, that is V1 is 24 voltage and C1 is a 2 microfarads, that is 48 microcoulomb. Q2 again, V2 is the same as a V1, 24 voltage, and C2 is a 4 microfarad, that gives you the 96 microcoulomb. And same you can find out the Q3, that is V3 into C3, that is 144 microcoulomb. So you can again replace all the capacitor, parallel capacitor with the this example shows the, you can replace the value of the C1 and C2 with the using equivalent capacitance value. Now C1 is a 4 microfarad and C2 has the C2 and C3 are in a series form, so 3 and 6. So ultimately what happens, C1 has the 4 microfarad and C3 and 2, 6 plus 6 into 3 by 6 plus 3, that is 6 plus 3, that is 6 into 3, 18 by 9, that is 2 microfarad. Yeah, so this is the equivalent capacitance value. Now C1 and C3 C8 are in parallel form, so ultimately in a parallel form the capacitor are summation, so we can make the summation of 4 microfarad and 2 microfarad and we get the equivalent capacitance, that is 4 plus 2, 6 microfarad. So you can replace all the C1, C2 and C3 capacitor with the only equivalent capacitor, that is 6 microfarad. Just find out the total charge, that is QT. Q equals to C into V. 6 microfarad is the overall equivalent capacitance and V is the 24 voltage. So that gives you the 144 microcoulomb. That is the overall charge. Now this is the summary of parallel plate capacitor. This is the overall equivalent capacitance in a parallel circuit. This is just one example, which is the complex circuit, just to find out the series and which are the capacitors are series and which are in the parallel. Just go through it. Just you have to mention that each and whenever you are connecting all the any capacitor between any two capacitor, just there is no node between that two capacitor. So you see that the B and P capacitor are in series, same the K, L and M are in series. You cannot consider C and D as a series because between two capacitor there is a node. So C and D are not in a series form. Same like H, Q, K, L, M are not in a series form because between H, Q, K, L, M, if you track the lines, you can find out that there is a two nodes. So remember one thing, in a series capacitor there is a no node between two conducting lines. Now the types of capacitor. The types of capacitor based on according to the configuration and according to the dielectric material used to make the capacitor. Now the configuration, dielectric material, polarization and the variability. According to the configuration, capacitor can be divided into spherical shape, into cylindrical shape and into the parallel plate. So if you make the conducting plate spherical, then it's known as a spherical capacitor, like that. If you make the capacitor to conducting plate cylindrical form, then it is known as a cylindrical capacitor, and all such kind of capacitor, between that the dielectric material is used. Last, in a parallel plate capacitor, the two conducting plates and separated with the distance d.